Hello, Calc. We're watching this on Monday, so that's the 3rd. It's, October already, October 3rd, and our topic is derivatives for sine and cosine functions. Alright, let us figure out how this works. Before we get into the meat of the discussion, I just want to remind you that the sign of a sum was not sine A plus sine B. No, no, no. It was sine A cosine B. Can you finish? That's half of it. Plus cosine A sine B. And so we used to know sine of A plus B, sine of A minus B, cosine A plus B, cosine A minus B. This one we'll need tonight, so bring that back to mind. Alright, I am going to actually prove to you what is the limit for y equals sine of x. I'm going to prove it by developing a proof with the limit definition and of a derivative. I'm proving the derivative of sine of x with the limit definition. The limit definition I'll use is the one that we're most familiar with. The limit as h approaches 0 of f of x plus h minus f of x divided by h divided by h. This is the difference quotient. Alright. Hope that doesn't get stuck in your mind. Alright, so now let us define y equals sine of x by this limit. So I'm going to say the limit as h approaches 0. What is f of x plus h when I'll put this in functional notation. Instead of y, I'll use f of x. So instead of putting in an x into our function, we're putting in an x plus h. So this will become sine of x plus h minus the function all over h. Alright, that doesn't look too bad. However, if we substitute h for 0, we get a 0 denominator, so we got to think of something to algebraically solve that issue. So I'm going to rewrite this using this. Alright, so putting that into action, the limit as h approaches 0 of sine A, which in this case is x, cosine B, which in this case is h, plus cosine A sine B. Alright, so using this idea, we have this for just this part right here. Sine x cosine h plus cosine x sine h. Alright. Minus, I'm up to the minus sign now, divided by h. Usually by now we're having fun crossing things out. Alright, so let's group some of these together. How shall I then do that? Let's take out a sine x out of this and this. Yeah, that'd be great. I'm going to do that. I'm going to remove a sine x from these two terms. And I think you might see where it's going to go from there if you don't already. So factoring a cosine out of those two terms and putting an h here. I think this is supposed to be sine x. I wanted to take the sine x out of these two terms. It's not that this isn't correct. It is, but it's not setting up the way I want it to. So let's take a regroup here. And I'm going to put that next to that. Sine x cosine h minus sine x. Just reorder it. Alright, I'm going to take the sine out of these two. See if that helps. Sine x, that leaves a cosine h minus 1. Yeah, oh yeah. Alright, and over here, I still have cosine x sine h. This h is under everything. Alright, now I'm going to set this up. Because this is added on the top, I'm going to do this expression over h and this expression over h, splitting it into two limits, because the limit of a sum is the sum of the limits. So I can do that. So I'm going to take the limit as h approaches 0 of sine x cosine h minus 1 over h plus the limit as h approaches 0 of cosine x sine h over h. So I did two things in that step. I divided this algebraically into two, this divided by h and this divided by h, and then I took the limit separately. Alright, so now you can probably see very clearly what's going on. Let's look at this first term. What is the limit as h approaches 0 of sine x? Well, sine x has no h in it. It's not affected by that limit. So I can pull it across the limit sign. And what's the limit of what's left here? Alright, that's a special limit that we learned. And that limit was 0. Wasn't it? Yeah. So we have sine x times 0 or 0 for that term. Alright, let's go over here. See can you envision what I'm going to do here? Something similar. What's the limit as h approaches 0 of cosine x? It's not affected. There's no h in it. The cosine x can cross the limit sign. And what limit is back of it? Sine h over h is a special limit. It is a big fat 1. So in this term we have a cosine x times a 1. Alright, so we end up with cosine x. So that's the final. This is 0 plus cosine x, which is cosine x. So what does that tell us? So here we are. We started with f of x equals sine of x. And we came out with the derivative. F prime of x is a way to say that. F prime of x is cosine x. So you're trying to tell me that the derivative of sine x is cosine x? Indeed I am. Let's see if that makes some sense in another light here. Alright, so I'm saying if y equals sine x, the derivative is cosine x. So I think you'll see that the graph will bear that out. So let's look at sine x. Alright, when we have sine x, I am going to take a picture of the derivative. So basically I'm going to ask myself, what's the slope doing up here? And I'm going to graph it down here. So this is going to be my function y, and down here is my function y prime, the derivative. So putting in the tick marks, let's do that. So let's go where the derivative is most easily accessible. right at pi over 2, what's the slope of the sine curve? It is 0. So at pi over 2, the derivative, I'm sure, is 0. Is there another spot on this curve where I'm sure of the derivative? Right here. It's also 0. So I can put a 0. I'll put a mark on the 0 there. What is the slope here? Well, just from drawing it, I can see it's not 0. And I can see the tangent line at that point is positive. And it looks like it's cutting right between the x and y axis. So that would be a slope of 1. So we're going to go out on a limb and say it's 1. And what if that's 1, what would be the slope of this one? It would be -1. Same thing but in the negative direction. And here, +1 again. So connecting all the dots of the derivative down here, I missed a dot there, it's supposed to go around like that. I have a picture of the derivative of the sine curve, and that is the cosine curve. So instead of doing the longer algebraic proof, let's look at what it shows up on when I go this way. Y equals cosine x. What is y prime? You might say sine x. Good guess, but wrong. Alright, so I'm going to draw the cosine curve. And I might be out of time, so let me have the dramatic conclusion on part 2.